Okay, so this is the third part. We call it advanced topics, but this means basically how to take everything that you learn, so the Python skills, using Bob for saving and loading data, doing machine learning, and how to complete that cycle that I talked about during the motivation. Okay. So what you're gonna learn through this hands-on here is how to download and install someone's package. So this is someone's work. For example, a publication, you know, the script that I have to generate the plots I use for a publication, for example. How to extend an existing package. So suppose, for example, I want to test somebody's work with my new data. How to create and roll out your own package. And how to upgrade and maintain your package, okay? Completing the cycle that you saw there. Again, the same image, now a little bit annotated. So basically just programs and everything. So what you're going to tackle is basically how do you start from, and you cover these two parts here, and in the end you not only have the publication, but you also have your code nicely organized so you can ship to somebody that can easily install that on their own computer and run the tests in a reproducible manner. Okay, so let me introduce first the concept of satellite packages. So satellite packages, as we call this in Bob, are just packages, okay? It's a container for sharing ideas, okay? And these ideas can be, for example, databases, utility programs, so anything you want to share with a colleague or that is required by lots of people, how-tos, unit tests. For example, as I just said before, how to reproduce exactly my publication, okay? So the properties that we're looking for in such a system is that it's easy to reuse, easy to install, and easy to maintain, and preferably that we don't have to implement, okay? So we just want to leverage from the existing open source stuff. Okay. So how do we actually use one of those satellite packages? And let's start with that, because that's the easiest. And the use case that we try to cover here is you read some publication, and somebody provided you with a URL of a package that reproduces that publication results. Okay, so what you want to do at this point is to hit that URL, download the package, and test it. Okay, so how do we do this? So I'll first ask you to open a terminal using your desktop. So this is a hands-on. Please do that. And if you're not on the directory which is called scripts, please cd into that. So that should be in the course scripts. Okay? Give you a few seconds to do that. In the scripts directory, you're going to find I already downloaded and pre-installed the package for you guys. But you imagine that you went through a download that actually you don't have to type. So cd into the directory of the package. So this package contains exactly or a very close copy of what you just did for the last hands-on. So that's the iris example, okay? And the first thing you have to do to use this package locally on your system, since you downloaded the code, is these two steps here. First, you're going to call Python bootstrap.py. At this moment, you must have an internet connection. Hey? So let's first try to do that. Python bootstrap.py on that directory. So what you're going to observe, and this I put here in 3 dots, is that the system is basically looking for the packages it needs for, but it's not installed locally, and is going to download them, install locally, and is going to set up for you a new script in a directory called buildout. Oh, there's a typo here. Okay, buildout without the B there. And this script is going to allow you to install the package locally. Okay. So after you ran through the bootstrap successfully, did anybody have a problem doing that? Just call Bing buildout without this B here. Bing buildout. And what you're going to see is that it's going to inspect the contents or the description of your package, download even further, or make sure that the packages are installed locally, or download from the internet, the other packages, and is going to instantiate the script that the user, the author of that package, has prepared for you. In this case, the script is called iris, so it's going to place the iris script on the bin directory. Please try that out. And you can actually run that script. And after you run the script, if everything went fine, you should be able to open the iris image. So basically, with 2 commands, I was able to download somebody's work and install it on my machine. Okay? So this is the kind of easiness we are looking for here. So now let me talk a little bit about the system. Has anybody not been able to see the iris example? The iris image, the PNG file generated. Okay? So let's look inside the package and see how it's actually possible. So if you do an ls-l using now the terminal again, in that directory, what you're going to see here is a bunch of files, okay? And there may be more files than the ones which I'm displaying here, but I'm going to focus your attention just on these 2 sets here. The first set of files that are here, they compose the package description. So there is some manifest file which tells which files within the package should be packaged with the package. This is useful for Python, for the Python packaging system. There is a readme.rst file. This is a restructured text format. If you open and inspect it, what you're going to see there is basically documentation that I've written myself for the package, maybe short. There is a directory called xbob that actually contains the code, the Python code that the user is going to execute. And there is a file called setup.py which describes my package properties, things like the name of the package or the version of the package, okay? And the dependencies of the package. So what other packages did this package need to run, okay? And there is a second set of files which is composed by these 2 files. The bootstrap.py, that's the first script that you used on the previous set of slides. So basically this allows the system to bootstrap the build-out infrastructure, okay? And there's a file called buildout.cfg, which explains build-out, what it should instantiate locally on the user machine. And normally this file is very simple, and we're going to look at it. And it allows build-out to actually download the resources and connect to the different servers and download stuff that it needs to. So the first thing I want you to do is to do a gedit on the setup.py file and have a look at it. This is the file that actually describes the package. So you're going to see some garbage in the beginning, just some preparation. But what it's most interesting here is basically the structure. You're going to see a big function that's called setup. And basically what you're doing here is just to parameterize the package. So you're going to think things defined like the name of the package. This is the name of the package. The version, a simple description. And you're going to see fields like install requires. So now this is interesting because it's just saying that for this particular package to run, it needs another package called setup tools and a version of Bob which is greater or equal 110. So what happens is that when you actually installed it locally using the buildout command, buildout actually went for you and checked and made sure that all these requirements were met before your script was even instantiated, okay? So you're sure that the script that the user has installed can run and all the dependencies are met, okay? And it also declares entry points. So in this case, it's just scripts, okay, that the package provides to the user. So these are things that buildout are going to instantiate for you locally on your bin directory. There will be a script called iris.py, and to implement that script, it uses this module here, okay? This module here from the example, so xbob, example LDA iris, the function main within that module. That's what it's doing, okay? So if you want to know, there are more fields that you can paste here in the setup script to define your own package. There's just more information on the link there. If you just click on the slide, you're going to be able to see that. Not very important. Now, a word on the build-out part. So, one thing is to describe the package. Okay, this package needs this other packages to run. It provides this script, it provides this library. The other thing is to make it locally runnable. Everybody that has worked with Linux here knows how it's difficult to install somebody else's package locally if you don't have root access. And what buildout is going to do is going to create a caged environment for you to install packages that you still don't have on your system but are required for this package to run. Okay? And the buildout configuration file, please just edit the buildout configuration. Let's look inside it. It's just a simple file that determines that basically we are going to be using the current package, okay, and some other configuration parameters you can actually find more information from at the buildout.org. So this is some sort of minimal buildout file that allows you to instantiate and make sure that the package is fulfilled in terms of dependencies and install the scripts it needs for running, okay, or the libraries it needs for running. Okay. If you want to know more about buildout, I advise you go to the web page and actually look at the tutorial. They have a very nice video tutorial explaining all the features, what it can do. It's a nice thing as well because you can extend it easily, so you can do complicated stuff like building packages locally, defining environment variables that you may need for executing locally and things like that. Important thing to know is that there are two things. One thing is the part that defines the package, that's the setup.py, and another part in the package that allows us to install the package locally without root privileges. So that's the second part. So now you know how to use somebody else's package. Now let's suppose you want to extend it. So suppose, for example, I have published some, revolutionary way to do something, and you would like to test that on your database. How easy can that be? So basically, what you're gonna want to do at this point is to download this person's package, and then implement a new script that uses your database instead of that person's database, but executes the same algorithm on your data, right? And you can see then how good it is on your data. So let's do that. Okay, so what we're going to do is the following. So we already have the example that runs the LDA, the official LDA algorithm on the Iris database. So what we'd like to do here is to take this other database, which is a wine tasting database, which is another toy example, okay, and to run the LDA algorithm on the same wine database. It's also a trickless problem if I'm not mistaken. Okay, so what we're going to need to do is the following. We're going to need to transform the script that the user provides, or to copy the user script and to edit, so that instead of using the Iris database, we're actually using our new wine database. So the first thing I ask you to do is to open the iris.py script, and let's look inside it. So what you're actually going to see is that the author was already very nice to us, because he has encapsulated the functions that actually train the machine, pass the examples through the machine, and do the plot in separated functions, okay? And by the end of the script, you're going to see how it's actually the definition of the function main that the package exports, okay? The function should be really small, have a few lines, in which basically we are loading the database data, training the machine, running the data through the machine, and plotting. Have you identified this part in the end there? Okay, so now you can quit this one, and let's open the other example which I have already pre-typed for you based on that, so you don't have to type yourself. So let's gedit the wine.py. So what you're going to see is a copy of the main function there, except that the data is coming from another package, okay? And for this example here, we are supposing that somebody has already pre-packaged the data into another satellite package that we don't have locally. So suppose that another colleague of yours was working with you and decided to package the data and the API to access the data into another satellite package. You know the package name, but you don't have it locally installed, okay? Because you're editing the new example of this new algorithm, this revolutionary algorithm that you want to test your data with. So you can close it down, and what we're going to need to do is basically to do the following. Let's open the setup.py file, and now let's tell the description of the local package that actually this package now to run requires another package, okay? And let's add this line with a comma in the end after the last line on the section install requires. So let's do that. So what we are telling is, we're telling to the setup system, my package now to require this other database to run, okay? And somebody has prepackaged already this database and put it somewhere, hopefully, if Laurent has done his homework. We're going to see that in a while. And because we just created the wine example there, we're going to declare and say that our package now not only has the iris script, but also has the wine script that runs the LDA algorithm on the wine database. So let's create this other entry there, identify where the section entry point is, and add this line here on it with a comma in the end. Okay. So what we're just saying is that the wine script.py that will be placed in the bin directory is implemented by the submodule xbob example LDA wine, the function main. Remember, when you added the wine.py, there was a function main there. So that's what we are saying here. Okay. I'll give you some time to do that. So once you have done this with the entry points, what do we need to do? Just rerun buildout. So what we're going to do is that we rerun buildout, and we call /bin buildout, and let's see what's going to happen. Normally, if everything went fine, it should print something like this. Getting distribution for blah, 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 and you're going to see here, getting distribution for xbob db wine. So it has found magically your package somewhere, and I'm going to talk about this somewhere later on, and installs it locally and make it available for a script to run, okay? And then generates your wine script. And you can now test it. Just run it. It should work. You can open the wine.png file that was generated by running wine.py. And you can see here now the LDA algorithm from this package applied to a new database, which I inserted myself there. Okay? So basically, improving somebody else's work is a matter of downloading the original package, extending it in the way I want, rerunning buildout, and be ready again to run. Okay? So very easy, very simple. Okay. This part here, you don't need to do, because it requires that you register on PyPy, and I'm going to talk about that in a short while. Okay, so what you found in your database, in your data, is revolutionary as well, and you now want to publish and you want to make it available for the next person. Say that's the next intern that comes after you, or say it's another PhD student that is working with you. You want to be able to share. So, technically, what you would need to do is just go to the setup.py, modify the package name. For example, I just gave here, I think the package is called xbob example LDA. You could put, for example, xbob example and your username there. And then you could push it into an index server, okay? So this PyPy, as people already has mentioned here before me, is basically just a huge server for packages, okay? So you can put there and deposit on the server any packages you produce yourself, or you can also use from the server packages that you would like to. So for example, the xbob db wine package was downloaded from that server. So what I propose we do now is we actually hit that link there, and we look at it. So basically, what you see here, this server has about 27,000 packages, so there's a bunch of packages here. You can publish yours. It's open source, and it's accessible to anyone. You can log in easily. And once you have logged in, you can upload your packages there. Okay? So this is a good way for other people to reuse your work. So they can link it on their own packages and the setups of their own packages, and just have that downloaded automatically installed locally so they can test it or use your stuff. Okay. So what can go into the package? So Python code, naturally, that's the bare minimum. You can also throw in database raw data if it's small enough. The Python package index has a limit of about 20 megabytes, if I'm not mistaken, last time I looked. So if your data is very big, what we do normally here, and we do have that use case, of course, in our group, we distribute the data through a portal and then provide just the package that explains how to use the data. It has functions that allows you to query the data for the different protocols that we have for testing, okay? Give me the train data. Give me now the development data. Give me now the test data. Run this through. Things like that, okay? You can also throw in test units so you can do quick checks. So if you change something on your package, you basically can quickly test it to make sure everything is still working. You can put documentation, and don't think documentation is necessarily to make it nice for the next person. It's basically to avoid to be interrupted all the time. If you type in good documentation, then people don't come and stop your work, all right? So that's always good. And you can also throw in C++ code. So basically, when Laurent was explaining here, when you find a bottleneck, you can just create C++ code just within the satellite package. That is going to be compiled and linked automatically using the same infrastructure I showed you before here, okay? Everything which I just explained here is available on this link here down. So if you hit that link, you can actually see a whole page that explains how you go from scratch, from having nothing to having a package, okay? That can work against other packages or standalone. Okay, so one important thing is version control, obviously. So how do you actually integrate that with your version control system? So in our group, we are using GitHub. So basically everything that we do goes through there. So the idea is basically that when you have a package, when you have an idea, so that you register a package somewhere, let's say on your version repositories, version control system, and you start developing it. And you integrate the several components that you want to integrate. And once you're happy and when you're about to release your publication, you just tag the package on GitHub, publish it on the Python index, and release the paper. Okay, that's as easy as that. So now people have access to your publication, to the data and how to actually compute the stuff with your publication, and to all the code that you actually use to generate those results. So EDApp has a portal on GitHub. So if you click on that link there, what you're going to see is a bunch of packages which are already pre-registered. So I guess some of you are already using it. One of the packages Bob. And Laurent has showed already our Bob page. There are others. If you want to open things, you just create a new repository here. You just have to file a ticket to help.edapp.ch, and they will open for you. It's Olivier and Philippe here that can open the repositories for you. So this is GitHub specifically. You don't have to use GitHub to maintain your code. You can use it if the code is about to be open sourced, okay? So for example, or is already open source and you want just to host it somewhere nicely. For example, suppose you're working on a publication and you'd like it to keep it private for the time being. So we also have the ability in this portal here to open some sort of private repository, okay, that is only accessible to you. And once you're happy, we can just flip a switch and make that repository public. Okay, so this is the kind of stuff that is provided automatically here and you can make use of. Again, just help.edapp.ch and you get help. Information on Git. If you ever want to switch to Git, I think it's a great version control system. So now let's review our original cycle and see if we have fulfilled or not everything that we thought on. You have an idea, so what should I do? You start or reuse a Git repository for that idea. Keep your source code always in a version control system. The idea is that one repo equals to one package, one idea. Okay? Then you start working on it. You are going to create your setup.py, try your build-outs locally to make sure that everything works. You should select the existing database packages, which are already available on PyPy. If not, you put it there, the same thing. Or create new ones, protocols, metrics, and data. Go into testing, and test and tune your algorithms until you're satisfied. Otherwise, you just continue on that cycle until you're actually done. Once the idea works, you write the paper, tag your code on GitHub, publish your package on PyPy, and you're done. You have reproducible research. Okay? People can download your code, given the support that you give for the different operating systems, but normally Python code, which simple works on any platform. You can test for people if the things are working. They can test for you, they can help you. You increase your potential impact, because now people cannot only read your paper, they can actually test your ideas on their own. And this affects directly your visibility, so it's a great thing. Where to go from here? Next steps. So as Manu already suggested, if you want to start with Python, just go to this URL. It's a great tutorial for starting. If you want to know anything about Bob, just hit our website. You're going to find all sorts of information there. If not, or if you find a problem, please report. If you want to help, please come. And I mean, we're always needing help with the different things. It's a very complicated system already. If you have doubts on any advanced topics besides the URLs already gave here, you can throw these issues on our mailing list. So we have links on the slides as well. So you can just click there and you're going to be taken to our mailing list. Otherwise, in trouble, just pass by our room. There's always somebody that can help you, either finding the answer or giving you the answer. For students that may be interested, this semester there will be a course on machine learning, so basic pattern recognition given by Sebastian with some help from me. And it was going basically to use the environment that you have already been introduced to, but apply it basically to pattern recognition. I guess that's it. I hope you have learned something new, if you already knew some of the things which I already said. Otherwise, yeah, that you have enjoyed the course. Okay, that's it. Thank you.